Okay, so today I'm going to talk about this Reconstruct Itinerary. Basically, the ticket says that, the problem states that we need to find the path for all of the connected vertices. Says that we reach the destination by lexicographical order. So here it's pretty straightforward, but for this one you could see that we can go from JFK to ATL and ATL to JFK. We could go to ATL to SFO, but you could see that ATL to JFK is less lexicographically when compared with ATL to SFO. So we follow this path. So that's why we do that, and the user starts at JFK, which would be this one. So let me start coding this up. So first of all, what we have to do is we have to create an edges just to store the several different edges that we find. I'm gonna create a default dict, and from here, what I will do is I'm gonna go through this in a reverse sorted order for the tickets. Therefore, I'll be getting the least at the last, so I can pop it out at the last. So this would be for ticket, and or we could do source comma destination and sorted of tickets. So this would sort in ascending order, so we want that to be descending. So this is the notation for the descending. So this would sort the list, the tickets list properly. And from then what we could do is we can append the source and destination here. We should append the edges properly. And now all we have to do is I'm going to declare a DFS approach, which would take in a source vertex here. And all we have to do is, let me declare a result in here. So in here, what we have to do is we have to iterate over the edges until they get exhausted. So which is edges of source. Now this will go through each and every single edges. Remember that the edges are sorted in a reverse order. Therefore, we're gonna get the lexicographically small element first. So what I want here is that I'm gonna remove that from the edge. I'm gonna pop it. So which would be the smallest element lexicographically. So, and I'm gonna call the DFS again. So what this will do is this is gonna take the destination again, and this will go again here, and this would go through the edges again, and this would do that in a recursive order, so that we get a path. And the final, after all this list is exhausted, the source would be from the reverse order. So I'm gonna append the source because this has been sorted in a reverse order. The last edge that will be processed will be lexicographically high value. Therefore, what we're gonna do is we're just gonna return this in a reverse order, and that should work. Okay, looks like I have to call the JFK here because we need to initiate the DFS, otherwise it won't work. Now you can see that this got executed properly. There you go.